Section 2.5 is called implicit differentiation. And really, today's lesson is going to kind of open up our ability to derive to a whole nother group of equations, kind of looking at things that aren't as directly stated. So, first, let me explain to you what it means to be implicit as far as an equation. So, this beginning part is kind of looking at what's the difference between an implicit equation and an explicit equation. So an explicit equation is one that is solved for a variable. We are most used to having y be that variable that it's solved for. So you're looking at all of these things here, y equals 3x squared plus 5, y equals sine of x, y equals x to the half tangent of x. I mean, you could look at anything we've been asked to derive over the course of the last week or so, and they have all been explicitly written functions. But there are functions and equations that are written without a variable being isolated. We call those implicit. Implicit equations do not have one variable that has been solved for. We can think of them as very simple ones, like this is one that you could solve for a variable with using a little algebra. And then you can run into ones that are basically a big mess of x's and y's kind of all intermingled and jumbled together. And these are not ones that there's any way to actually separate. I couldn't give you that equation and say, I want you to get x by itself or I want you to get y by itself, just because of the complexity of the equation. So to look at equations that are written implicitly, we have to have another way to do this. We have to have another technique. This isn't really necessarily a rule for derivatives. It's more of kind of a technique to how do we address something that looks a little different. So in the bottom, we talk about what does it actually mean when I write dy over dx. What it actually means is it's the derivative of y with respect to x. So when I derive a really simple explicit equation, I often write y prime, just honestly because it's easier to write. But what you're actually doing here is that this left side, you're saying, well, the derivative of y is dy over dx, and the derivative of this side is just a very simple power rule. So without really thinking about it, when there was a y there, you actually did put something on the other side. You put often y prime, but that's the same thing as saying dy over dx. And that's going to come into play as we look at how we derive things that have these y's kind of jumbled in. So it's a four-step process, and it's a very algebraic process to do an implicit derivative. So I have this first one, and you'll notice it's definitely an implicit equation. You kind of have x's and y's that are all jumbled together. Two of the terms on the left have x in it, two of the terms have y in it. And the directions are to find the derivative. And it often will say find the derivative in terms of x's and y's, because your answer will actually be both variables when you're done. Four-step process, and I'm going to kind of explain the process as I do the process. So I'll kind of like write a step and then do the step. So step one, you are going to derive both sides using all your known rules. So you still may have product rules, you have power rules, quotient rules, trig even shows up. But the biggest difference is when you derive y, you need to put dy over dx, because that is the derivative of y. It is dy dx. So looking at my first equation here, my first term is x squared. The derivative of that is 2x. My next term is y cubed. So I'm going to do a power rule, power out front, power 1 less. But because it is a y term, you also have to include dy over dx. Kind of think of it as like it's like a chain rule almost. The inner piece, the inner part is a y value, and the derivative of y is dy dx. Now, I've had students say, well, why don't I have to do anything like that for this term? Well, if you did that for this term, you would say it's the derivative of x in terms of x. So you would have like a dx over dx, which would cancel out completely. So that's why it is not necessary when you're deriving an x term, but it will be necessary when you're deriving a y term. Then the derivative of negative 5x is negative 5. Then the derivative of 2y is 2 dy over dx, again, because you're deriving a y term. And then your equal sign. And then the derivative of 5 is 0. So that is step one. And to be honest, it's the only calculus step out of the 4 steps, is to look at each term, derive each, use whatever rule necessary from what we've learned. But keep in mind that anytime you derive a y term, you will have to include dy dx. Step two, it's kind of a rearranging term. You're going to have a whole bunch of terms here. Some will have dy dx, some won't. You want to separate. You want to put all your dy dx terms on one side, and you want everything without dy dx. So without dy dx, you want to put on the other side. Basically, it's like a reorganizing. So currently, I have these two terms that have dy dx, and I have these two terms that don't. It does not matter which side you move to. I'm going to move the non-dy dx's. So I'm going to move the 2x to the other side by subtracting it, and I'm going to move the -5 to the other side by adding it. And I still have a 3y squared dy dx on the left, and I still have a 2 dy dx on the right. So basically, it's a rearranging of terms. Step 3, now that you have ensured that everything on one side has dy dx, you're going to factor that out front. So whichever side you decided was going to be the dy dx side, it's the side that's going to have a dy dx factored out, and you're left with 3y squared plus 2 when I do that, and nothing needs to happen on the right side. And then your last step, remember, the idea is that you want to know what dy dx is. The goal is to find the derivative expression. And so the only thing I have to do to get dy dx by itself is to divide. So your final answer is -2x plus 5 divided by 3y squared plus 2. And you'll notice your answers for implicit derivatives are much bigger. They're very often rational because of the dividing, and they are in terms of both variables. They are in terms of both x's and y's. It will always take these 4 steps. You will probably get to a point after you do these for a while that you feel like you can skip steps, and that's totally fine. But I want to make sure I'm doing each step individually so I don't lose anybody along the way. So let's do a couple more here. I'm going to break today up into 2 videos, kind of really basic ones, and then show you a few tougher ones at the end. So one of the things you're going to notice when you're asked to do implicit, especially on the AP test, they love to put product rules within your implicit equations. And I say that because this first one, right off the bat, you're going to hopefully look at that and say, oh, that's x times y. That's a product rule. And so you want to look for that. You really want to look to see product rules. They also do a lot of things with negatives. I feel like negatives always kind of negatives drive me crazy. So first times the derivative of the second, the derivative of y is dy dx. You can put 1 dy dx if you want, but you don't have to. Plus the second times the derivative of the first. So the second is y. The derivative of x is just 1. You don't have to write it. You can if you'd like. Notice this one does not have a dy dx in it because you didn't derive y in this part of the product rule. Then we're going to keep going. The derivative of 2x squared is 4x. The derivative of 3y is 3 dy dx. And the derivative of 10 is 0. So again, you have some terms that have dy dx because you derived a y and some that do not. So I'm going to move the ones that don't. That's just out of habit for me. So I'm going to move the y, and I'm going to move the 4x, and I'm going to keep the x. And here's where you can kind of combine steps if you'd like. I will often have students go right to the next step, which is factoring out the dy dx from what has it. And then finally dividing. So your final answer for your derivative is -y minus 4x over x plus 3. So let's talk about signs for a second because they are often missed. If you rearrange differently than I did, what I mean by that is I moved the non-dy dx's and kept the ones that had it. If you do the reverse, which is perfectly fine, what you'll see as far as impact in your answer is all of your signs will be the reverse of mine. So if you have positive y, positive 4x over -x, -3, it's still right. So that is one thing to notice is sometimes just depending on how you choose to move things, your signs could all be the opposite and still be correct. Now you can't have like some of them be opposite and some of them the same. It's basically an all or nothing. All right, next one. Derivative of 3x squared is 6x. Derivative of 7 sine y, I don't know why I had trouble saying that, is 7 cosine y times the derivative of y, which is dy dx, equals the derivative of 3 is 0. The derivative of 8xy, here's another product rule. So it is, I'm going to put the 8x's together and then the y together. So when I say like the first and the second, the first is going to be 8x, the second is going to be y. So first times the derivative of the second, the derivative of y is dy dx. plus the second times the derivative of the first. So the derivative of 8x is 8. And then you have the y. And that one does not have a dy dx because you're not deriving a y term. So I'm going to do a lot of rearranging here. I'm going to bring this dx term this way and this non-dx term this way. So I have 7 cosine y dy dx minus 8x dy dx. And on the right side, I'm going to have the 8y that was there and then the minus 6x that joins it. So then I'm going to factor out my dy dx, which leaves me with 7 cosine y minus 8x equals 8y minus 6x. And then finally, I'm going to divide by 7 cosine y minus 8x. And again, your answers are kind of messy. When you type them into Delta Math, you just have to make sure you have the right parts in the numerator and the right parts in the denominator. You do not need to try to simplify them in any way. And that is your derivative. So that's the basics. I'm going to do one more video that just extends it a little bit, but it gives you an idea of how to start.